Welcome back to the deep dive. You know that specific feeling when you learn a new word and then suddenly you start seeing it absolutely everywhere?
The Bader-Meinhof phenomenon, frequency illusion.
Exactly. Well, I feel like globally we're all having this massive Bader-Meinhof moment with artificial intelligence. Feels like we went to sleep in 2019, woke up, and suddenly AI was, writing poetry, passing the bar exam.
And generating images of the Pope in that big white puffer jacket.
That one was everywhere. It was a bit of a cultural whiplash, wasn't it?
Massive whiplash.
But we've got a fascinating stack of sources today that suggest this sudden explosion is actually a total myth. They argue that what we're seeing now is really the climax of a slow burn that's been sizzling since the days of black and white TV.
That's so true. If you want to understand why, say, Microsoft Word is suddenly offering to rewrite your emails, you can't just look at the last 5 years. You have to go all the way back.
Back to post-World War II.
Yeah, back to code breakers, room size calculators, and a very different definition of what a computer even was.
So that's our mission for this deep dive. We're going to trace the family tree of AI from the human computers of the 1950s all the way to the deep learning models we use today. We'll break down the tech.
Specifically, how machines actually learn.
Right. And then we'll get really practical about how you can use these tools without embarrassing yourself.
And maybe most importantly, we need to demystify this whole idea that computers are thinking, because there is a huge difference between a chatbot that can predict the next word in a sentence and a being that actually understands what that sentence means.
I think that distinction is going to be the theme of the day. But let's start at the very beginning. The sources highlight something I hadn't really thought about. In the 1950s, the word computer, it didn't mean a box on your desk.
No, not at all. It was a job title. If you looked at the payroll for NASA back then, a computer was a person.
A human being.
Specifically, there were groups of these incredibly brilliant women who were solving complex differential equations by hand, figuring out things like rocket launch paths.
This is the story from the movie Hidden Figures, right?
Precisely. But here's the thing. Humans get tired. We make tiny calculation errors when we're fatigued. So as the math got harder and the stakes got higher...
Like, putting people into orbit.
Exactly. Scientists started asking, can we build a machine to take over this cognitive load? Can we sort of mechanize thought?
Which brings us to the grandfather of it all, Alan Turing.
You really can't have a conversation about AI without Turing. I mean, he was instrumental in cracking the German Enigma codes at Bletchley Park during the war. But for our purposes, his biggest contribution came a little later with a paper he wrote proposing the imitation game.
Which everyone now just calls the Turing test.
Right. And the concept is deceptively simple. Imagine you're a judge in a room. You're typing messages to two players hidden behind a wall. One is a human, one is a machine.
And I'm just asking them questions. What's your favorite color? Or how does a sunset make you feel?
Exactly. And if, after 5 minutes of conversation, you cannot tell which is the machine and which is the human, then the machine is said to have passed the test. Turing argued that if a machine can mimic human responses that, well, we should consider it intelligent.
But this is where our sources, and a lot of philosophers, really push back.
Yes.
Does fooling me actually mean the machine is thinking?
That is the million-dollar question, isn't it? And it's probably more relevant today with things like ChatGPT than it was in Turing's time. The Turing test, at the end of the day, measures mimicry, not understanding.
The source used a parrot analogy, which I found really, really helpful.
It's the best way to visualize it. If a parrot says, I want a cracker, does it understand the concept of hunger? Or the nutritional value of a cracker?
No.
No. It just knows that making that specific sound usually results in a reward.
So when I ask a modern AI to write me a sad poem, and it produces something that actually makes me a little teary.
It's just a very sophisticated parrot. It doesn't feel sadness. It's predicting the next likely word based on billions of examples of sad poetry is analyzed. It's all math, not emotion.
Okay, so that's the philosophical limit. But let's look at the mechanical side. How did we get from a theoretical imitation game to a machine that can actually learn? Because standard software, like Excel, it doesn't learn.
Right. Standard software is totally rigid. If you type 2 + 2, it will always equal 4. It doesn't wake up one day and decide to try 5. But back in the 1960s, a guy named Arthur Samuel at IBM did something different. He wanted to teach a computer to play checkers.
And checkers is a game of strategy.
It is. Now, he could have just programmed every possible legal move into the computer, but that's not really learning. Instead, he programmed the computer to play, and this is the breakthrough, he programmed it to remember the outcome of its games.
So if it moved a piece to a certain square and then lost, it would remember not to do that again.
Exactly. It adjusted its strategy based on experience. It played thousands and thousands of games against itself, constantly refining its own probability of which moves lead to a win. That whole concept, adjusting based on error, that's the birth of machine learning.
And around this same time, the sources mention Frank Rosenblatt and the perceptron. This sounds like a Transformers villain, but it was really an attempt to model the human brain, wasn't it?
It was. Rosenblatt was a psychologist, and he wanted to build an artificial neuron. To explain this, the source uses a great analogy, our recycling plant sorter.
I love this visual, so let's walk through it. Imagine a conveyor belt.
Right. And trash is coming down the belt, paper and plastic. The perceptron is the robot arm that has to decide which bin does the piece of trash go in. Now, how does it decide? It needs criteria, let's say. Weight and flexibility.
Okay, so the machine has sensors. Is it heavy? And does it squish?
Exactly. Those are the inputs. The perceptron assigns a weight to these inputs. And I don't mean physical weight, I mean importance. Maybe it decides that heaviness is the most important factor. If an item's light, it's probably plastic, so it tosses it in the plastic bin.
But wait, what if it's a crumpled piece of paper? That's also light.
The machine gets it wrong. It puts the paper in the plastic bin. A human supervisor or the code itself says, error, that was paper.
So the machine has to learn from that.
Right. And learning here is just math. The machine adjusts the numerical weight it gave to its criteria. It says, okay, heaviness wasn't a good predictor. Let me increase the importance of squishiness next time. It just does this over and over until it gets the sorting right.
So learning is really just automatic error correction, but on a massive scale.
That's it. You've hit the secret sauce. You're just minimizing error through repetition.
It sounds like they had it figured out in the 60s. I mean, we had checkers, we had artificial neurons. Why didn't we have ChatGPT in 1970?
We hit the AI winter.
Sounds bleak.
It was, at least for the researchers. The expectations were just sky high. People thought we'd have robot butlers by 1980. But the hardware just couldn't keep up. These algorithms, even simple ones like the perceptron, they require a lot of calculation. And the computers of the 60s and 70s were huge, expensive, and incredibly weak by today's standards.
The brain was there, but the body was too weak.
That's a great way to put it. So funding dried up, and AI became a bit of a joke in academia for, well, about 20 years.
But obviously, the ice thawed eventually.
The 80s and 90s brought two huge things, personal computers and the internet. And suddenly, we had data. So researchers started trying to tackle specific senses again, like vision.
Computer vision. This is where the source talks about the struggle of just teaching a computer to see a ball.
It's hilarious in hindsight, isn't it? We take it for granted now, but teaching a computer to tell the difference between a red ball and a blue cube was a doctoral level problem. They were using edge detection, literally programming the computer to look for the mathematical curve of the ball versus the sharp right angle of the cube.
And this was happening on, what, low-resolution webcams?
Oh, it was primitive. But it was the start of robots interacting with the physical world. The source mentions robots painting cars, using a camera to find the window so they didn't just paint over the glass.
It's very narrow, but it's practical.
And that's what defined that era, narrow AI. Same thing with language. We had the ancestors of Siri, but they were just keyword spotters.
Oh, like the old automated phone menus. Please tell us why you are calling.
And if you said, I'm worried about my bill, it would just freeze. But if you said the keyword balance, it worked. It was just hunting for specific words, not understanding your intent.
So what changed? I mean, how did we go from hunting for keywords to the system we have today that can summarize a 50-page legal doc in 3 seconds?
That brings us to the 2010s, the boom. And it happened because of this perfect storm of three things.
Let me guess. Better computers.
Yes, but specifically a new approach called deep learning. Remember the perceptron, the little recycling sorter?
Yeah, deciding between paper and plastic.
Yeah.
One decision.
That was one layer of decision-making. Deep learning stacks those layers one on top of the other. It creates a neural network.
The source breaks this down into input, hidden, and output layers. I want to spend a second on the hidden layer because that sounds really mysterious.
It's where all the magic happens. So let's say you show the computer a picture of a face. The input is just the raw pixels. The first hidden layer might just identify basic edges where dark meets light. The next hidden layer combines those edges to identify simple shapes, circles, triangles. The next layer combines those shapes to identify features, an eye, a nose.
So it's building understanding from the ground up piece by piece,
Exactly. It's hierarchical learning. It learns the components to understand the whole. And to do that, you need massive, massive amounts of data to train on.
which the internet provided.
We uploaded billions of photos, tweets, and articles. That was the fuel. But you also needed an engine powerful enough to process it. And this is the part I love. The engine came from video games.
The GPU.
Graphics processing units. If you're a gamer, you know these. They were designed to render these complex 3D worlds, explosions, lighting, textures, all at the same time.
And it just turns out that rendering an explosion is mathematically similar to training an AI.
It's all about parallel processing. Think of a normal computer chip, a CPU, like a really fast race car. It's incredibly quick, but it can only do one task at a time, sequentially.
Okay, so it's fast but serial.
Right. A GPU is like a bus. It's maybe slower than the race car, but it moves 50 people at once. When you're training a neural network, you have to do millions of tiny calculations simultaneously adjusting all those little weights we talked about. GPUs were already designed for parallel tasks, so they were this accidental perfection for AI.
The source mentions that these chips are now so valuable they get delivered in armored cars.
It's true. They are the new gold. Because without them, deep learning simply doesn't work at this scale.
So we have the data, we have the chips, and we have the deep learning architecture. That brings us to today, the summer of AI. And for most of our listeners, this isn't about robots anymore. It's about Microsoft Word.
Right. This is where the rubber really meets the road. The source spends a lot of time on Microsoft Copilot, which is basically taking this massive deep learning brain and sticking it right inside of Office.
I've played with this a bit. It is not just a spell checker on steroids.
No, it's a generative engine. It's meant to be a creative partner. You can highlight a paragraph in Word and say, rewrite this to be more concise, or change the tone from angry to diplomatic.
And the source is really specific about this. You have to know how to ask. They call it prompt engineering, which sounds really technical, but it's just communication skills.
It really is. If you just type, write a letter, you're going to get garbage. Microsoft actually recommends this 4-step framework for a good prompt. I think we should walk through it because it's genuinely useful.
Okay, let's do it. 4 steps. Step 1, goal.
Be specific, not write a letter, but draft a welcome email.
Step 2, context.
Who is involved? This is for a new senior project manager joining the engineering team.
Step 3, expectations. This is the tone, right?
Right. Keep it warm and casual, but also emphasize our focus on punctuality.
And the last step, 4, source.
Yes. Give it material to work with. Use the onboarding schedule that's in this PDF attachment.
So if I put that all together, goal, context, expectation, source, the output is going to be infinitely better than a generic prompt.
It's night and day. It transforms the AI from a guess machine into a targeted tool. And it works in PowerPoint, too. You can feed it that Word doc and say, create a 10-slide deck based on this, and it will generate the slides, pick the layouts, and even find stock images.
That sounds like a dream for anyone who hates making slides. But there's a massive but here.
The rough draft rule?
We cannot just click generate and then email it straight to your boss.
Absolutely not. These models hallucinate. They just make things up. Or in PowerPoint, it might pick an image that's totally inappropriate for the context. You are the pilot. The AI is the co-pilot. It gets you maybe 80% of the way there, but that last 20%, the verification, the judgment, that has to be you.
It changes the workflow from creation to more like editing.
Which is faster, for sure, but it requires a different kind of attention.
Now, we need to zoom out a bit. We've talked about the tech and the tools, but we should talk about the impact. Because letting algorithms make decisions or generate content isn't without risks.
No, and this is where we have to distinguish between what we have now and what people are afraid of. People hear AI and they think of AGI, artificial general intelligence, the sci-fi machine that can do anything a human can do. We are not there.
We have narrow AI.
Right. It's just really, really good at specific tasks, like, say, customer service chatbots.
We've all dealt with them. The airlines love them.
It's a double-edged sword, though. For an airline, if a storm cancels 500 flights, a human call center just collapses. An AI can handle 50,000 requests simultaneously. It's efficient, but it has zero empathy. It doesn't care that you're missing your sister's wedding.
And sometimes you just need to scream at a human.
Exactly. AI really struggles with nuance in those unique edge cases.
There's also the privacy side. The source tells this story about a student named Maya that I found, well, really relatable. I want to walk through her morning because it illustrates data-driven decision-making perfectly.
Let's do it.
Okay, so Maya is scrolling Instagram. She's been getting into running lately. She pauses on an ad for wireless earbuds.
Stop right there. That pause. The AI logged it. It knows she didn't just scroll past. It registered interest.
So she clicks, goes to the website, checks the battery life, but thinks too expensive, and closes the tab.
But the website had a tracker on it. It knows she looked at the noise cancellation model specifically.
The next morning she wakes up, checks her email.
And boom, there it is. Hey, Maya, still thinking about these. Here's 10% off.
It feels like magic, or maybe a coincidence.
It's neither. It's an algorithm connecting her social media identity to her browsing history and then triggering a personalized incentive to close the sale.
It's convenient. She gets the discount, but it's also, a little creepy.
That's the modern trade-off. We pay for all this convenience with our data.
And that data accumulation leads to huge security risks. The more data a company collects, the bigger the target it becomes.
And we've seen this with massive breaches like Equifax. 148 million people exposed. But I want to pivot this to a specific warning for our listeners who work in offices.
The difference between public AI and enterprise AI.
This is so crucial. If you are using the free public version of ChatGPT and you paste your company's confidential quarterly strategy into it and say, summarize this,
Where does that data go?
it potentially goes right into the training set for the public model. You have just taught the public AI your company's secrets. There have been actual cases of engineers pasting proprietary code into these chatbots to check for bugs, and then that code becomes part of the model's knowledge base.
Yikes. So, moral of the story, don't do that.
Don't. That's why companies pay for enterprise tools like Copilot. They have a walled garden. Your data stays within your company's system. It is not used to train the public model.
So if you're at work, check which version you're using before you paste the secret recipe.
Always.
So pulling all of this together, we've gone from Turing's theoretical game through the failures of the AI winter to a world where we have supercomputers rendering 3D worlds and writing our emails. It really does feel like we're in a transition period.
We are. We've moved from the AI winter to the AI summer. The technology is incredibly powerful. But the biggest takeaway for me is that it's not magic. At the end of the day, it's math. It's just prediction.
And it seems like the role of the human isn't disappearing, but it is shifting.
That's the key. AI changes the how of work. It automates the drafting, the summarizing, the pattern recognition, but it leaves the why entirely to us.
The judgment.
The judgment, the ethics, the creativity, and the final decision. You can't outsource your critical thinking to an algorithm. If Copilot writes a bad letter and you send it, you sent the bad letter, not the computer.
That's a great reality check. These tools are collaborators, not replacements. We're still the pilots.
Precisely. The goal isn't to compete with the machine, but to learn how to direct it effectively.
Well, I certainly feel a lot better equipped to look at that little Copilot icon on my taskbar now. It's not a magic button, it's just a very, very powerful calculator.
Just don't ask it to feel sad about your poetry.
Deal. Thanks for diving deep with us today.
My pleasure.
And to our listeners, next time you get a targeted ad for something you're just thinking about, remember Maya and the algorithm working in the background? It's not fate, it's just data. Until next time.